type. So, Kirsten, you recently sat down for a fascinating discussion with Professor Guy Midgley from Stellenbosch University, the School for Climate Studies, and you dove into the deep history of the African penguin. I didn't even know that the African penguin had a deep history, and how it relates to climate change, or the window that offers us into climate change. So I was wondering, what was your highlights from that conversation?
Thanks, Johan. I would say that, first of all, Professor Guy Midgley has got just such an amazing, charismatic curiosity to him. And he is really able to, or he was able for me to join the dots between the species, survival, and science. So he jumped from the African penguin, which he went into quite a lot of detail, to the southern right whale, to threatened, very biodiverse vegetation types, and he linked them all together. And the penguin, as well as a whole suite of other species, animal species that evolved during the Pleistocene period, which was 2.5 million years ago, were actually adapted to a temperature that was about 5 degrees less than what it is now. And they have actually gone through a series of ups and downs of temperature and evolved to handle those changes. But what he was saying is that obviously with the world warming so rapidly, those species might not be able to adapt enough to survive. He did say that the penguin was very resilient, and that gave me a little bit of optimism for it.
Okay, fantastic. So without further ado, please join us for this conversation. And as always, you're welcome to share this conversation with others and enjoy it.
So Guy, please tell me about yourself.
I'm currently the director of the Stellenbosch University School for Climate Studies, and I have been so for a couple of years. Mm-hmm. My career really started as a plant physiologist, and I was trained in plant physiology actually here at Stellenbosch University in the 1970s. And I took up my first position in the early 80s with the Botanical Research Institute as a technical sort of lab assistant type person. Mm-hmm. Assistant agricultural researcher, I was called. And, you know, I became interested. I worked in desert ecology for several years and became interested in climate change issues in the late 1980s. And then asked my boss at the time, because I'd finished my master's at that stage, if I could do a PhD on CO2 effects on plants. Because at that time, the warming of the world was very much misunderstood and was very uncertain. But we knew that CO2 was going up, and I knew that CO2 affected plants very, very strongly. And so I did my PhD on that, and that led to, one thing led to another. I ended up starting up a group in the National Biodiversity Institute, because the BRI, Botanical Research Institute, went through a couple of different iterations. And then under Professor Brian Huntley, it became the National Biodiversity Institute, and he gave me the opportunity to build a climate change, global change program. And I did that for many years until 2014, when I resigned and came back to Stellenbosch to pursue an academic career for what I thought would be the last 10 years of my career. But it's now been extended happily by Stellenbosch for another 5 years to continue on building the School for Climate Studies.
And what is your absolute passion in your academic life?
My academic life, my passion, oh my gosh, quiver trees. It's really about scientific puzzles, putting patterns together, that aha moment when you suddenly see something that hasn't been seen before, and it makes sense. Mm-hmm. And you put together the evidence, and the story emerges. It's my passion. It's really understanding the human, social, ecological world, and how people and the natural world interact and how to make it sustainable. There's some big questions there which are unendingly interesting to me.
I'd like to ask about the other side of Guy. I happen to know that you like the ocean and waves.
I do. I have a very misspent youth paddling around the Atlantic Ocean on little bits of foam and dressed in a wetsuit, chasing waves, which somewhat got in the way of my studies, to be honest. But I don't regret a minute of it. But yeah, no, I've spent a lot of time in the ocean, and it's something that, it's very much a constant in my life. So I still try to get to the ocean as much as I can these days.
Super. Thank you for that, Guy. Fascinating life journey. And I think it's continuing in gusto. I'd like to head back to the penguins. And I'd like to understand your thinking around what is special about the African penguin and in comparison to other penguins.
Well, I think that we as Cape Townians and South Africans should be much more aware of how incredibly special these little birds are. They are survivors of very rapid and very extreme climate change in deep time. And I say this because the African penguin is currently not quite as ecologically, let's use the word happy, as it has been for most of its evolutionary history. Because the African penguin, as we've discovered in my group here, was far more numerous during the ice ages, during the coldest period of the Pleistocene, which is an epoch that lasted 2.5 million years, just prior to our current epoch, the Holocene. And the African penguin evolved and proliferated during that period, when the world was about 5 degrees colder than even before we started warming the world naturally, warming the world through greenhouse gas emissions. And our work shows that it was almost certainly much more numerous in the tens of millions of birds around Southern Africa. And so when the world warmed naturally at the end of the last ice age cycle, which was 18,000 years ago, it looks to us very much as though the African penguin became a climate refugee, a climate relic, which has happened multiple times in its evolutionary history. But every time it's survived that warming, that natural warming trend, which is driven by the natural cycles of the world orbiting the sun and various other natural drivers. So this little bird has been able to tolerate and adapt to, mainly through migration, past rapid warming and cooling events. And it has that built into its genetic makeup. But what's happened now is that we're warming the world much warmer than we have seen over the last 2.5 million years. And it's going to test the resilience of this little bird quite considerably. So the African penguin represents a particular kind of biodiversity, an ice age dependent biodiversity that is quite widespread in the northern and southern hemispheres, that is enormously at risk under future climate change, under human-induced climate change. And that's why, it's one of the reasons why it is so special and why we should value it so much.
Why is the African penguin under such environmental pressure?
The African penguin is under pressure not only because of climate change. In fact, at the moment, I would say human climate change is not one of the most pressing issues facing the African penguin. It's really mostly threatened by the loss of habitat, which was induced originally by harvesting of guano, which reduced the availability of nesting sites for penguins. So when guano began to be harvested for phosphorus in order to fertilize crop growth, it removed a really ancient and very valuable ecological resource for African penguins. So they've had to change, in many ways, they've had to change their nesting behavior. And then more recently, our incredibly efficient harvesting of seafood, of fish, which directly competes with the penguins' food sources for human consumption, has been really devastating for penguin populations. And also penguins have suffered because of oil spills in the past, so there have been some really devastating oil spill events which have hammered penguin populations. Those are the main issues. And what's happened today, quite extraordinarily, is that penguins are nesting in places that they never normally would have nested. So they're nesting in Simonstown. That would normally never have been a natural nesting place for penguins, because without humans, they would have been subject to predation by leopard and caracal and other predators. So penguins are highly dependent on island habitat to nest and to survive. And it's just quite ironic that despite all these human pressures, it is human protection that is creating some real centers of penguin resilience. And that's also something very special. I mean, it's an incredible dependence that penguins have on humans, while at the same time being enormously threatened by people. So isn't that ironic?
Do you, just recently there's been all these closures around penguin colonies and islands to prevent overfishing in those areas, so that the penguins can feed their chicks and put up weight. I know that they are very skinny and undernourished because they're just not getting enough fish. Do you think that those closures are a good conservation measure, or a sufficient conservation measure?
Without a doubt. I think I've heard, I hope I'm not making this up, so please fact check me, but I think I've heard that there's already some evidence that some of the closures are having some benefits. As I said, they're very resilient birds. They're incredibly resilient. They're able to shift and find new nesting sites very rapidly, because they've had to do it in the past, in their evolutionary history. It's in their evolutionary history. So they are pre-adapted in that way. And that's why I've always said, if we can give the penguin half a chance, it is worth protecting. It will fight its way back. It's a very resilient bird. It's an incredibly important bird ecologically. And there would be absolutely no excuse if the penguin went extinct. That would be a case of such human mismanagement and just gross negligence. There would be no excuse. This is a species that is really able to bounce back.
So there's space for optimism.
100%. This is a fighter.
Amazing. What does the case of the African penguin tell us about the way that climate change affects wild species in general?
Yes, that's a lovely question. It tells us a couple of important things. Number one, it tells us about the resilience of nature to past climate change. Now, of course, people then say, well, climate's always changed in the past, so why are we worried about future climate change? But this is why it's so important, because it indicates to us that the past climate changes, at least for the last 2.5 million years, have involved much cooler conditions. And so when somebody says to you, the climate's always changed, why are we worried? You need to ask them, well, how has it changed? And see if they know the answer to that question, because I can promise you they probably won't. And the answer is, well, yes, climate has changed, but it has been colder. So many, many species around the world, most of them, have been through a sequence of colder spells. And so they're naturally adapted to much cooler conditions and lower CO2 conditions, actually. So a world of lower CO2, cooler, drier, less productive. It's a world that kept human populations hugely under control. It's only once the world warmed and CO2 rose that the human species was able to start farming and increase its numbers so substantially. It was really an ecological niche shift that humans went through about 9,000 years ago. But so that's one thing the penguin tells us, is that it helps us understand the nature of past climate change and the fact that it was much cooler. And then the other important thing it tells us is that there are a whole suite of species and biomes and ecosystems that are dependent on those cooler, more glacial conditions, because they're the dominant condition for the last 2.5 million years. So if you think about the migration routes of southern right whales, we currently think that they migrate these long distances, and how did that happen? How did they evolve that? There are also a lot of other species do these migrations. How did that come about? Well, during glacial times, the distance between the areas that these species were using for migration were much smaller, because the Antarctic was had a much larger coverage, came much closer to the coast of southern Africa, to Australia. So southern right whales, as one example, were migrating far less. And it's only as the Antarctic shrank, the world warmed, that they then kept tracking the breeding and their feeding zones. And so they got that set up because it was so much easier. It was so much more ecologically, I shouldn't use the word easy to do, but it made ecological sense. And then as the climate warmed, well, they just kept following their patterns because it happened over a few thousand years. They were able to adapt. But we're now putting species like the southern right whale under stress because we're widening that distance even more. So females have to migrate so much further between the feeding and the breeding grounds. And so there are hundreds, possibly thousands of species that are suffering these additional stresses because they were already under stress because of natural warming, and we're exacerbating that stress, we're making that stress worse. And I think that's why a lot of the ecological models predict extinctions with reasonably low levels of climate change. And I think it's these very vulnerable Pleistocene-dependent species. One of the biggest groups that I'm aware of and that I'm very worried about, and a lot of people are the succulent species of the succulent Karoo, because that is a Pleistocene ecosystem. And all those little succulents are very dependent on cooler, reliable rainfall conditions, and they just don't have the capacity to adapt as fast. So it teaches us a lot about past climate change and how important it is to understand past climate change when thinking about the risks of the future.
You earlier referred to deep history. What do you mean by that?
It's a good question. I mean, for some people, deep history is a couple hundred years. In ecological time, that's a few seconds. If we think about deep history, the deep history of humans is about 300,000 years. So we've been on the planet for about 300, maybe 350,000 years as a modern human species. So in one sense, 300,000 years is deep history for us because it takes us to our very origin. But for modern ecosystems, deep history is 2.5 million years, which is the start of the Pleistocene. And in fact, could be more like 15 million years, which is the time period when CO2 dropped low enough for ice caps to start forming. So that, in a way, for me, that becomes proper deep history. And then if you go even deeper, it becomes super interesting because you go back 30 million years, the world was a completely different place. The CO2 levels were 1,500 parts per million, quadruple what they are today. There were no ice caps. Sea levels were 100 meters higher. The world was covered by forests. We had no savannas, we had no grasslands. It was an entirely different planet. So that is, deep history in terms of modern ecosystems. So during those times, we had no modern African ecosystems. The iconic African ecosystems, the savannas, succulent Karoo, grasslands, really start to rise about 15 million years ago, Miocene, Pliocene, and into the Pleistocene. So African systems are also modern ecosystems, low CO2 dependent ecosystems, cooler adapted ecosystems. And that's why our African ecosystems are so vulnerable to climate change.
Fascinating divergence from my penguins. So back to the penguins again. What can we learn about species adaptability and conservation responses to climate change from the African penguin?
Species adaptability is something that you can infer a lot from the evolutionary history of a species. So the African penguin has had to cope with rising and falling sea levels, the flooding and opening up of islands. And you can imagine, if you think of the African coast, during the Ice Age, the sea levels were about 100 meters lower than they are today. That opened up a vast 100 kilometer long, 100 kilometer wide plain south of the Agulhas. So think in your mind's eye, if you're standing at the southern tip of Africa, you'd have 100 kilometers of fynbos, probably limestone fynbos, slightly swampy, covered by game. That would have been the status quo for southern Africa for the last 2.5 million years, about 60% of the time. That's what it would have looked like. And so species that exist in this part of the world would have adapted largely to those conditions. And so we learn a lot about adaptability by understanding what happened when the climate warmed naturally. So how did species migrate? And the penguin teaches us a lot about that. So the penguin had to cope with a whole different set of islands on which to nest. These would have been inundated as the sea level rose, and then they would have had to island hop, find a new island. And you can, as we have done, we've written a paper in our group where we mapped how the island habitat changes and new islands become available. And it tells us very clearly that the resilience and adaptation of the African penguin is through an ability to migrate as it loses its habitat. And we can see that playing out today. If you establish a new population, as has been done in De Hoop, if you protect it, they will thrive. So the African penguin tells us a lot about the role of migration and adaptability. Sadly, there are many species that don't have the same resilience, and particularly in the plants. But we can learn a heck of a lot now.
So I'm going to diverge again about the plants. I'm just fascinated to hear why they're not adaptable or adapting.
The plants of the fynbos and succulent Karoo, these floras are renowned because of their very, very high biodiversity. And it's somewhat, I wouldn't say it's a mystery, but science isn't 100% sure exactly why this region is so biodiverse. And there are a number of explanations that have been put forward, but it's virtually certain that one of them is the fact that for the last 2.5 million years, the oscillations in climate that we've been talking about that move penguin populations around the place have been operating in the mountains and on the plains of the Southern Cape. And there have clearly been these climate oscillations, but they have not been sufficiently fast or extreme to drive the extinction of a wide range of plants that have developed very specialized interactions with the insect and animal world. So things like long-tongued flies pollinate particular plant species. those sorts of specializations can only evolve and remain in an ecosystem if the climate does not change too much, because with very rapid climate change, you split apart. You can easily split apart and tear asunder those specializations. Another hint is from ant dispersal in many proteoid species. So many proteas have evolved a seed that has an attachment which attracts ants, and then ants will pick up the seed and go and bury it. So they can disperse as far as an ant can drag a seed. Mm-hmm. Now, there's no way that that strategy is going to work under extreme fast climate change. So there's another hint that if climate change had in the past been really rapid, those sorts of species would have gone extinct. They didn't. Mm-hmm. So this is very likely a part of the world where fairly modest oscillations in climate change, and the fact that it became wetter during glacial times because the winter rainfall zone moves further north, so it becomes wetter, it becomes colder. That has helped to retain all these specializations. And when that happens, nature can just explore the available niche space through all these specialities, because because they're more efficient. And so the reproductive efficiency is what drives the speciation, despite the fact that if climate were to change really fast, they would become very vulnerable. So to prove the point, if you go to the northern hemisphere, into the forests of Europe, Canada, and you drive through those ecosystems, you'll drive for hundreds of kilometers seeing the same species over and over and over again. Why? Why aren't there more conifers? Well, it's because those areas had very extreme climate change. They were covered by ice. And the species that you find there generally have long distance dispersal abilities, wind dispersed seed, bird dispersed seeds, and you get none of these very specialized insect-plant interactions, or very, very few, that you get down here. And that's another hint from biology about climate history. So I was saying these are things that sort of I'm passionate about. It's about, there's so many lenses that you can use to understand how things work. And so I've just used the lens of intercomparison between the hemispheres. Mm-hmm. That can be a very powerful tool in understanding biogeography. And so you've got to, I'm really excited, interested in that, doing these north-south comparisons. So you can, east-west, different continental comparisons. That's, it teaches you a heck of a lot about how the world really works.
So big question. What would you say is the most important riddle that we need to solve at this time in science?
I think that it is, if we want to maintain what we've become accustomed to in many parts of the world as a civilized lifestyle, our biggest riddle is how to properly engage our economic system with the planetary ecological system in ways that are mutually supportive. And there's really no reason we can't do that as a global species. I'm talking about the we as all humanity. But the answer is not that obvious. And we've become a very modern species, having developed economics, and we're very highly dependent. Our societal structures are highly dependent on the concepts, but they are archaic and poorly understood in the context of ecological functioning. That's what we've got to figure out, and to do that in a way that lands us and keeps us within this safe, sweet climate spot that we've been in for the last 9,000 years. If we were to deviate significantly from the last few thousand years of climate conditions, life would be much harder for human society. So it's about keeping us in, around about 300 to 350 parts per million CO2, and that would help us stabilize the climate in a way that would be most beneficial for most countries and most people on the planet. That's really the zone that we need to be in. And at least we know that answer. That's very clear. We know that answer. So we know what to aim for. It's how do we get there? And that's a battle.
And we've got some good brains and passion working on it.
Maybe more of us should be writing some useful books about how to do that. But it takes, I think it's a multidisciplinary, transdisciplinary question. And there's no single brain that can do it. It's got to be done by teams of people who understand all those aspects well enough. And it's got to involve, the current business practices. These are all things that help to contribute to a good life. I do not believe in going back to sackcloth existence, living hand to mouth. I don't think that's where we want to be either. Yeah.
So Guy, this might sound a bit dramatic, but are we going to, as the human race, are we going to go out with a bang like the dinosaurs? Or as you spoke about earlier, are we going to be more resilient like the African penguin?
Well, I must say that it's a novel thought, but my response to that, given our understanding of past human adaptability, is that we're very unlikely to go out with a bang like the dinosaurs. Human species is extremely adaptable. We've become very modern, and as I say, we've shifted our ecological niche into agriculture and becoming dependent on farming. That's not our natural state in the deep time perspective. So I would imagine that even if there were to be some very significant political or ecological disaster, that people are going to survive, and that but it would be, we would live again more like the hunter-gatherers of deep time, and just like most other species, I would imagine that human beings would be extremely resilient, but it would be a very, very different form of life. We would be living from hand to mouth, no time to do any science, no time to enjoy reading, that sort of thing. That would all just go by the wayside. It would just be a case of surviving. But we would survive, I'm pretty sure. But I don't think I doubt that, because it's happened in the past.